In order to keep abreast of their peer-reviewed literature, practitioners of medicine, allied health, and nursing need to be able to interpret information dispensed in the form of graphs, charts, tables, and equations. This 48-minute module describes these nonverbal strategies for data presentation and leads the viewer through several exercises that serve to acquaint us with the advantages and drawbacks of each of these paradigms. All of us encountered rectilinear coordinate systems, or XY plots, in high school algebra and geometry. These concepts are reviewed because they're encountered frequently in the reports of various clinical studies. Successive points are positioned within an XY plane and connected with a straight line. The mathematical and geometric attributes of the line that we've scribed are examined in order to provide us with a formula for the line that can be used to convert between centigrade and Fahrenheit temperatures. The concepts of slope and y-intercept are explained both verbally and diagrammatically, enabling us to appreciate the relevance of these concepts to our understanding of physiologic phenomena. The module then proceeds to enumerate the advantages and drawbacks of various modes of data presentation, verbal, tabular, and diagrammatic, using examples that have been extracted from the peer-reviewed literature. The verbal mode is used to describe the interaction between carbon dioxide tension and hydrogen ion concentration in arterial blood. Next, the tabular representation of this interdependency is demonstrated by means of a table published in a classic monograph by Dr. Newton Brackett and his research team. Those same data are then presented in graphic form by means of a chart that is incorporated in the same paper. Next, a formula that accurately and precisely depicts the response of Homo sapiens to progressive degrees of carbon dioxide retention gleaned from the same publication is provided. It is indisputably true that practicing RCPs need to be thoroughly acquainted with the physiology that governs acute, chronic, and acute-on-chronic hypercapnia. Owing to the high incidence of chronic obstructive pulmonary disease in the patient populations that they serve. The methodical and systematic development of this topic enables the learner to appreciate the unique advantages of graphs, charts, tables, and equations, and reinforcing their understanding of these important concepts. The presentation then proceeds to describe a web-accessible computer application, or app, that builds upon the principles just described and employs the case of an actual patient who presented to an emergency medicine physician with a severe case of CO2 retention. The RCPs who navigate through this lesson will encounter patients of this type from time to time, and they can exploit the benefits of this app to assist their physician colleagues by using the clinical decision support tool represented by the app. By the time the user navigates to this point of the lesson, she or he will have reviewed and examined the graphical presentation of data pertaining to two variables on the familiar XY plane. But now the module will examine the manner by which three independent and interdependent variables can be represented diagrammatically, the triaxial system. First, we will build a triaxial system using screen capture software. The three axes thus erected will be used to depict the three variables which interact to determine acid-base balance in arterial blood: the carbon dioxide tension, the bicarbonate ion concentration, and the hydrogen ion concentration. These axes will be arranged geometrically to form an equilateral triangle, the acid-base triangle diagram. And various regions within that triangle will be identified by means of labels and colors to indicate the particular acid-base disorder associated with them to form the acid-base triangle map. This paradigm has been coded as a computer application, or app, to spare bedside clinicians from the mundane chores of scribing lines, and the requisite tasks are achieved under computer control by the acid-base ClinimapEd. The module concludes with a description of the manner by which this app can be used as an electronic preceptor's assistant to enable seasoned RCPs to teach the intricacies of ABG interpretation to students and junior colleagues.